Today we're going to learn how to figure out empirical formula from percent by mass data. There is a little rhyme that might help you remember this. It goes like this: percent to mass, mass to mole, divide by small, multiply till whole. So let's try it. According to our little rhyme, it says percent to mass. So the first thing we're going to do is we're going to take our percentages and convert them to masses. As we spoke about in lecture, we're going to use 100 grams for convenience. If you assume that there are 100 grams total, then it makes the math so much easier. If you assume that there are 100 grams total, that means then that you would have 48.38 grams of carbon. You would have 8.12 grams of hydrogen, and the rest is oxygen. So in order to figure out how much oxygen, we'd have to subtract from 100, right? We only have three things. All percentages must add to 100. So we have 48.38 plus 8.12 means that the total carbon and hydrogen makes up 56.5% of the sample. So if we subtract that from 100, we determine that there are 43.5% oxygen, which means 43.5 grams of oxygen. So this is step one. This is percent to mass. Step two is mass to mole. Okay, so let's convert all of our masses into moles. This is a step you should be fairly comfortable with by now. We have 48.38 grams of carbon. 1 mole of carbon weighs 12.01 grams. Okay, we have 8.12 grams of hydrogen. 1 mole of hydrogen weighs 1.008 grams. And oxygen, we have 43.5 grams of oxygen. 1 mole of oxygen weighs 16.00 grams. So let's go ahead and plug these into our calculator. Okay. 48.38 grams divided by 12.01 should get you 4.028 moles of carbon. 8.12 divided by 1.008 should get you 8.056 moles of hydrogen. And 43.5 divided by 16 should get you 2.719 moles of oxygen. So that's part 2, mass to mole. Part 3 of our little rhyme says divide by small. Right, so percent to mass, mass to mole, divide by small, and multiply till whole. So divide by small is, of course, the part where you divide all three of these by the smallest, thereby forcing one of the three to be 1. The smallest in this case is 2.719. So 2.719 is what we're going to divide everything by. Okay, 4.028 divided by 2.719. Tells us that for carbon we get 1.48. For carbon, okay, 8.056 divided by 2.719 is 2.96. It's for hydrogen. And 2.79 divided by 2.719 is 1 for oxygen. Then part 4 of our rhyme says multiply till whole. Multiply till whole. Okay. Obviously the 1.48 is not a whole number. 2.96 is, right? That's pretty close to 3, and 1.00 is. So the only one we need to make whole is this one. However, since this is a ratio, anything we do to 1, we must do to everything. Hopefully you recognize that 1.48 is very close to 1.5. 1.5 times 2 should get you to 3. So multiplying 1.48 times 2 gets you 2.96, which is very, very close to 3, close enough to round. So we will have 3 carbons. Now, because we multiplied the 1.48 times 2, we must also multiply everything else by 2. So 2.96 times 2, which is essentially 3, gets us 5.92, which is essentially 6. So C3H6. And then oxygen is 1. 1 times 2 is 2. So our empirical formula is C3H6O2. So again, this isn't so bad if you remember our little rhyme. Percent to mass, mass to mole. Divide by small, multiply till whole. Thank you for listening.